Hello, everyone, and thank you for the introduction. Today, I would like to draw your attention to our fragment screening and hit validation capabilities. The HITS platform is part of Wuxi's research service division. At the beginning of 2020, Wuxi's Stealth screening unit joined forces with Germany-based Crystallography in Munich, a 100% subsidiary of Wuxi AppTec. As you can see, we offer services at the early stages of drug discovery programs and support our clients, especially at the target and hit finding stages. Our key expertise lies in customized protein production, DNA-encoded library screening, in short DEL, fragment-based screening, and biophysics hit validation, as well as structural biology. First of all, some general considerations about why we offer fragment-based screening. One reason is that it is complementary to classical HTS and DEL screening. In fragment screening, we work with rather small molecules with a size of 200 to 300 Dalton. Due to their size, they can bind to small pockets available on protein surfaces and thus provide a good starting point for inhibiting protein-protein interactions. One big advantage is that fragments are quite simple chemical starting points. This allows for more flexibility during hit-to-lead optimization. The fragments can be grown, linked, or merged. And this allows a very efficient way of sampling chemical space. The chemical simplicity also allows efficient optimization of pharmacokinetics in parallel with potency as the fragment hit grows into a clinical candidate. Finally, hit rates from fragment screening are excellent indicators for the druggability of a protein target. Before we dive in, a few words about the design of our fragment library that was done with strong support from medchem experts at Wuxi. The library contains fragments from e-molecules, lab network, and proprietary Wuxi fragments. To select appropriate fragments, we applied various filters to remove frequent hitters, known false positives, molecules with reactive groups, or that interfere with assay formats. All fragments are synthetically accessible, show appropriate complexity, and are Rule of 3 compliant. In summary, we selected 3,100 fragments representing key pharmacophores. Now let's talk about the starting point and a very critical point for fragment screening, the protein production. At HITS, we offer customized protein production solutions. We tailor protein towards the needs of the screening format. We offer recombinant protein production in different hosts. At Crystallography, we also have very high standards for protein quality, as it has a large impact on the quality of biophysical screening and structural data. For every lot that we produce, we run SDS page and analytical sec to check for purity and monodispersity. We perform intact mass and mass spec fingerprint to validate protein identity and post-translational modifications. And last but not least, we confirm protein activity by making use of our biophysical assay platform. In summary, we always produce proteins that are the best possible solutions for downstream assays. Over decades, we have produced over 1,500 proteins. Once the protein is available, we are getting to the biophysics and screening stage. In our biophysical and biochemical assay platform, we offer more than 10 different assay formats. Currently, for fragment screening and hit validation, our main working horses are microscale thermophoresis, in short MST, the second generation instrument dianthus that uses the phenomenon called TRIC, nano-DSF or classical DSF, and SPR. These methods offer fast turnaround times. We also have the flexibility to change between different methods depending on the target's requirements. We have optimal starting material in hand and can check for the best possible assay format. Only once we have identified the best assay format for each target, we start the screening campaign. With our platform, we can not only identify hits, but characterize them in detail. We can determine binding affinity, kinetics, and thermodynamics. Besides our working horses, we also use NMR, ITC, DLS, ASMS, FP, or biophysical assays as routine assay formats. Now I want to give you a more detailed overview of our screening workflow. First, we produce the protein and run a QC by SDS page, analytical sec, and MS. Then we use nano-DSF to optimize the assay conditions. We screen for an optimal assay buffer, detergent, and DMSO concentration. We also confirm protein activity using tool compounds. Based on this information, we perform an extended assay setup. We investigate which technique, MST, dianthus, or SPR, is most suitable for the screening. Once a technique identified, we run a single point screening followed by an affinity ranking of the identified hits. And this typically takes 2 to 4 weeks. Afterwards, the identified hits are validated by an orthogonal biophysical or biochemical assay. We also recommend our clients to set up a suitable crystallization system in parallel. This can be a soakable or a co-crystallization system. Further down the road, we can support you by SAR by catalog or with in silico approaches. In the following 2 slides, I will show you some real-life data of a case study that we performed with the stimulator of immune response genes, in short, STING. The construct was designed with a His and an AppTec, such that fragment binding could easily be analyzed by MST and SPR. For MST, we established non-covalent labeling of the His tag with red NTA dye. The assay was validated by demonstrating reproducible binding of 2,3-CGAMP, the natural substrate of STING, with 10 nanomolar affinity in line with published data. We ran a primary screening at 1 concentration, followed by a KD affinity ranking. And the best fragment hits exhibited binding with KD values in the 2 to 3 digit micromolar range. For orthogonal validation, we made use of our assays that we established in-house. On one hand, by SPR, immobilizing STING to a streptavidin chip by the biotimulated AppTec. On the other hand, nano-DSF. And by that, we were able to confirm 66 binders. We also decided to validate a subset of these binders by STD-NMR, and the data was really encouraging. 9 out of 11 selected hits were confirmed by NMR. After biophysical screening and hit validation, typically a next step in these kind of projects is structural validation of the hits by X-ray crystallography, which we also offer at HITS. So you will find here a general overview of the crystallization workflow. Ideally, we establish a soaking system for the target protein. This enables setting up crystallization trials at very high compound concentrations. The data is automatically processed and hits are manually refined. In case of success, this opens up all possibilities of structure-guided drug design and would then also involve our medchem experts at Wuxi. With this, I would like to conclude my talk. I thank you for your attention and I'm happy to answer your questions.